All right, these two learning targets. We're going to know and use the triangle angle sum theorem, and we're going to know and use the exterior angle theorem. So you got to know them, you got to know what they say, you got to be able to write them down if you're asked, you got to be able to do fill in the blank on them if you're asked, true, false, if I change a word, you got to know them. Then you got to use them. All right, you can't use them if you don't know them. On page 244, we have the triangle angle sum theorem, and this gives us the relationship among the interior angle measures of any triangle. Now, you might think, well, all the angles are interior. Well, you're correct so far. Okay? It says the sum of the measures of the angles of a triangle is 180. So if you add the measure of angle A plus the measure of angle B plus the measure of angle C, it will equal 180. So no matter what kind of triangle it is, whether it's acute, obtuse, right, equilateral, isosceles, scalene, it doesn't matter. No matter what kind of triangle you have, the sum of the measures of the three angles will always equal 180. Okay? How often will the sum of the measures of the angles equal 180? Always. Every single time. Okay. Now, here, remember when we ran into auxiliary line earlier? And only a few of you bothered to look up what an auxiliary line is? All right, it says here that the proof of this theorem requires an auxiliary line. An auxiliary line is an extra line or segment drawn in a figure to help analyze geometric relationships. So, there's your definition of auxiliary line. All right, let's do a few problems from today's assignment. All right, these are on page 248. Find the measures of each numbered angle. So for number one, we have a 63-degree angle and a 59-degree angle and then a missing angle. Well, we know that the three angles have to have a sum of 180. So we're going to be able to, when they give us the numbers, we can probably do this either in our head or on our calculator. But here's the way it works out algebraically, right? The measure of that angle plus the measure of the next plus, and then call the missing one x, plus the measure of that last one equals 180. But whether you're writing it down or just doing it in your head, aren't you going to add the 59 and the 63? And what do you get when you add 59 and 63? 122. So whether you're actually writing it down, and I do encourage you to do this in your head. Calculator if you have to, but I encourage you to do this in your head. Okay? So whether you've got it written down, whether you've got it on your calculator, or whether you've got it in your head, isn't the next step to subtract 122 from 180? Because that way you'll know what that missing measure is. Well, what is 180 minus 122? And so the measure of the missing angle is 58. So it's not very often a math teacher tells you this, but I'd actually, when they give you the numbers, now, they're not always going to give you numbers. A lot of times they're going to give you expressions, variable expressions, and you'll have to write your equation out. But when they give you the numbers, I'd really rather you be able to do it in your head. Now, you got to be careful. You do. You got to be careful. Subtracting from 180, like I've warned you about already this year, it's really easy to be off by 10. It is. It's just easy to be off by 10. So be careful with that. Number two. All right, let's see. They need us to find the measure of this angle, and this one, and this one. All right, and I don't necessarily know which one I need to find first, but it looks like I can find angle 1 first, okay? Because look what angle 1 is. So let's ignore the other two for a moment. Let's find the measure of angle 1. Looking in this triangle right here, if I know the measure of two of the angles, I can get the third by doing what we just did in number 1, correct? So I've got 90 plus 48. What's 90 plus 48? 138. So then the measure of angle 1 is whatever you add to 138 to get to 180. In other words, it's whatever 180 minus 138 is. And what is 180 minus 138? It's 42. Okay? Now, I think I need to get angle 2 next, because with angle 2, I can do this. I have a pair of parallel lines. Here's a transversal. So 39 degrees and angle 2 form a pair of alternate interior angles. So what's the measure of angle 2? 39. Now that I have that, let's look at this triangle right here and use the triangle angle sum theorem again. I now know that's 39. So 90 plus 39, whatever I get, subtract it from 180. What is 90 plus 39? And what is 180 minus 129? What is it? It doesn't look like a 5, does it? And there we go. So far, so good? Okay. Now let's let's learn about and then use the exterior angle theorem. All right. First, we got to know what an exterior angle is. In addition to its 3 interior angles, a triangle can have exterior angles formed by one side of the triangle and the extension of an adjacent side. So, because remember, lines don't stop just because we stop drawing them. So see what they've done here? They extended AB and made a line or a ray out of it instead of just a segment. So that's one side of the exterior angle. And then that side BC, segment BC, which is the side of the triangle, is the other side of that exterior angle. So that's how you get an exterior angle. You can make one at each vertex. See, I could do that. Then I could extend this one and use that side. An angle 5 would be an exterior angle. And then I could extend this one and use that side, and angle 6 could be an exterior angle too. And if I extended different sides, I could get different exterior angles at each one as well, couldn't I? Okay, so you can get exterior angles. You can get them at each vertex. All right. Now, each exterior angle of a triangle has 2 remote interior angles. So let's look just here at angle 4. Okay? There are 3 interior angles. Always 3. No matter what exterior angle you draw in, there's always 3 interior angles. In this case, angle 1, angle 2, angle 3. One of the interior angles is adjacent to our exterior angle, correct? Angle 2 is adjacent to angle 4. So there's one adjacent interior angle. What's the relationship between those 2 adjacent angles, angle 2 and angle 4? They're supplementary because they make a linear pair. Okay? So there's one adjacent interior angle, which means there are 2, count them, 2 remote interior angles. Think of remote as meaning at a distance. A remote control controls the TV from a distance. Okay? A remote island is way away from everything else. So it's at a distance. So there are 2 interior angles that are a distance away from our exterior angle, angle 4. Now there's a special relationship here between those remote interior angles and the exterior angle. And here it is. The measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles. The measure of the exterior angle equals the sum of the measures of the remote interior angles. Or you might think of it as the sum of the measures of the remote interior angles equals the measure of the exterior angle. Because that's the way they actually wrote their example out. Angle A is one of the remote interior angles. Angle B is the other one. Add their measures together, and it equals the measure of that exterior angle. Questions? Okay. Let's try a couple. So back to page 248. We're supposed to find the measure of angle 2. Well, use the exterior angle theorem. Okay? The exterior angle theorem says that the measure of the exterior angle, in this case 112, equals the sum of the measures of the remote interior angles. So 32 plus whatever the measure of angle 2 is. So all I need to do is subtract 32 from 112, isn't it? What is 112 minus 32? It's 80. So 80 equals the measure of angle 2. Now, I got a question for you. If I'd never shown you the exterior angle theorem, could you still have figured out the measure of angle 2? It'd take you another step, but you could get it. Tell me how you'd get it. Yeah, those are supplementary, so I can find that missing one. What's the measure of that missing angle in the triangle? And then I use the triangle angle sum theorem, don't I? I would add the 68 plus the 32, and I'd get 100. So then 180 minus 100, and that one ends up being 80. Huh. Isn't that funny how the two theorems we have today are kind of all related and work out together? No, that's not funny. It has to work that way, doesn't it? If they're both true, don't they have to work together? Okay? So does that make sense? You see how you can use some combination of these two theorems to figure out a whole lot of different things now? Let's try number 4. We're supposed to find the measure of angle MPQ. Well, this is a direct use of the exterior angle theorem. All I got to do to find the measure of this exterior angle is find the sum of the measures of the remote interior angles. So what is 56 plus 95? So the measure of angle MPQ equals 101. Everybody still with me? Any questions? All right, everybody likes the chair problems. The brace of this deck chair forms a triangle with the rest of the chair's frame as shown. Everybody sees the little triangle. Angles 2, 3, and 4 are the interior angles. If the measure of angle 1 equals 102, so draw this figure on your paper. Don't draw the chair. Draw the important part. And then let's label the measures they give us. The measure of angle 1 is 102. And the measure of angle 3 is 53. And then they ask us for the measures of all the other ones. Now, there's definitely more than one way you can go about this. Okay? For instance, when I labeled the measure of angle 1 to be 102, I kind of, without meaning to, figured out what the measure of angle 2 is. What's the measure of angle 2? 78, because 1 and 2 form a linear pair. I don't need anything from today to figure that out. So I can label that as 78. Well, I kind of also figured out the measure of angle 6 when I labeled angle 3 as 53 for the same reason. 3 and 6 are a linear pair. So what's the measure of angle 6? So that's 127. Okay. Now, let's get angle 5 next. Let's use the exterior angle theorem to get angle 5. Angle 5 is an exterior angle of this triangle, so its measure is equal to the sum of the measures of the remote interior angles. So the measure of angle 5 is equal to 78 plus 53. What is 78 plus 53? 78, 53, 131. And then I can get angle 4. I can get it a bunch of different ways. Angle 4 and angle 5 are supplementary because they're a linear pair. I can do that. Angle 2 and angle 4 have to add up to 127, don't they? Or 78 plus 53, whatever that is, subtract it from. So like I said, there's definitely more than one way you can go about a problem like this. I didn't even have to do it in the order I've done it so far, right? So however you do it, what is the measure of angle 4? It's 49, okay? 49 and 131 are supplementary. 49 plus 78 equals 127. And 78 plus 53 would be, didn't we do that a while ago? It's 131, so then 180 minus 131, 49. All right, so, you know, we can even double check our answers. Does 78 plus 53 equal 131? Yeah. Does 49 plus 53 give us 102? And see how I'm doing this? I'm adding the remote interiors, making sure I get the exterior. 49 plus 78 add up to 127. Yeah. So we've got them all. So the number 5, the measure of angle 4 is 49. Number 6, the measure of angle 6 is 127. Number 7, the measure of angle 2 is 78. Number 8, the measure of angle 5 is 131. Questions? All right, now we have 2 corollaries. A corollary is a theorem. It's proven true. It's called a corollary if it's a direct result of another theorem. So they are standalone theorems, okay? They're proven to be true, but these 2 at least are called triangle angle sum corollaries because they are both a direct result of the triangle angle sum theorem, okay? The first one says the acute angles of a right triangle are complementary. Well, think about it. They have to be, don't they? According to the angle sum theorem, the triangle angle sum theorem, the sum of the measures of those 3 angles is 180. Well, if one of the angles is 90, don't the other 2 angles have to have a sum of 90? So that 90 plus 90 gives you the 180? And so if the measure of angle A and the measure of angle B is 9, or if the sum of the measure of angle A and the measure of angle B is 90, then angle A and angle B are called complementary angles. Make sense? There can be at most one right or obtuse angle in a triangle. This is also a result of the triangle angle sum theorem. Think about it. If there were 2 right angles, that's already 180 degrees. The third angle can't have a measure now. It would have to be 0, and if it's 0, then it's not there, is it? Okay? And then what if there's one right and one obtuse? Well, it's like playing 21. You already busted, didn't you? You're already over 180. Your third angle can't be negative. Okay? 2 obtuse angles. You busted. The third angle can't be negative. So there can be at most one right angle or one obtuse angle in a triangle. Let's do 3 more examples and I'll let you work. What's the measure of angle 1? How'd you get 61? Yep, that's what I would do. 90 plus 29, looking at this triangle right here, is 119, and then 180 minus 119 is 61. That's the way I'd do it. Okay, I think I want to get measure of angle 2 next. That seems easier to me. What's the measure of angle 2? Yeah. How'd you get that? Yeah, these 2 angles right here form a linear pair. They're supplementary. Okay? Or, is there another way I could have gotten the measure of angle 2? Yeah. These are the remote interior angles. Angle 2 is an exterior angle of this triangle we started with, isn't it? So the measure of angle 2 is equal to the sum of the measures of the remote interior angles. 90 plus 61 is also 151. So two good ways to get the measure of angle 2. All right, now that we know this is 151, what's the measure of angle 3?
12.
It's 12. How'd you get it?
Oh,
Yeah, I would use the triangle angle sum theorem. 151 plus 17 would be what? 168. 180 minus 168 gives us 12. Any questions? All right, on page 248, do the first 11, then do 13 through 23 odd, 24 through 32, do all of those, 38, and 52 through 55.